When two things are similar, they may look alike, but they are not identical. Suppose you have chocolate chip ice cream and chocolate fudge ice cream. The flavors are similar, but not exactly the same. If two triangles are similar, they have the same shape, but they are not the same size. When working with similar triangles, we use this symbol that looks like an equal sign that's been tipped on its side with one additional line. Let's say that triangle ABC is similar to triangle DEF. We write this as triangle ABC is similar to triangle DEF. Now, to prove that two triangles are similar, we need to show that corresponding angles are equal, or we need to show that corresponding sides are in proportion. In this video, we will work with corresponding angles. So, what exactly are corresponding angles? Let's start by drawing two triangles. Let's name our first triangle ABC, and we can name our second one PQR. I'm also going to write the name of triangle ABC down here and PQR down here as well. We know that we name a triangle by its three vertices, and we name the three interior angles by those vertices as well. The name of each triangle shows us the corresponding angles. The first letter in triangle ABC is A. So let's mark A in red. The first letter in triangle PQR is P. So let's mark angle P in red as well. A is the first letter in ABC, and P is the first letter in PQR. So A and P are corresponding angles. B is the second letter in ABC. So let's mark this angle in green. Q is the second letter in PQR. So let's mark this angle in green as well. B is the second letter in ABC, and Q is the second letter in PQR. So B and Q are corresponding angles. Finally, C is the third letter in ABC. So let's mark this angle in purple. R is the third letter in PQR. So let's mark angle R in purple as well. C is the last letter in ABC, and R is the last letter in PQR. So these are corresponding angles. If angle A is equal to the corresponding angle P, and if angle B is equal to the corresponding angle Q, and C is equal to the corresponding angle R, then we have two similar triangles, and we can say the triangle ABC is similar to triangle PQR. Now we have a general idea of corresponding angles, so let's look at some examples. Consider the triangles ABC and EFG. Prove that these triangles are similar. Let's consider the corresponding angles. A is the first letter in ABC, so let's mark angle A in red. E is the first letter in EFG, so we can mark this angle in red as well. We can see that angle A is 70 degrees and that angle E is 70 degrees. So we know that corresponding angles A and E are equal. When working in geometry, any information you write down is known as a statement, and for every statement, you need to give a reason why you believe the statement to be true. We know that angle A is equal to angle E, so we can write the statement down over here. The reason why we believe these angles are equal is because the question has given us this information. So, as our reason, we simply say given. If we are using any information given to us in the question, we always use the term given as our reason. Now we can look at B. which is the second letter in ABC. And we can mark this angle in our diagram in green. F is the second letter in EFG. So let's mark this angle in green as well. We can see that both angle B and angle F are 60 degrees. So we know that angle B is equal to angle F. And we can write our statements over here. We know that angle B and angle F are both 60 degrees because the question has given us this information. So again, we use given as our reason. Finally, let's look at C. C is the last letter in ABC. So let's mark angle C in purple. G is the last letter in EFG. So let's mark angle G in purple as well. Angle C and angle G are both 50 degrees. So angle C is equal to angle G. And we can write this statement over here. Once again, we know these angles are equal because this information has been given to us. So again, we use given as our reason. Now let's look at the information we have found. Angle A is equal to its corresponding angle E. Angle B is equal to its corresponding angle F. And angle C is equal to its corresponding angle G. All three pairs of corresponding angles are equal, which means that these triangles are similar. So we can say triangle ABC is similar to triangle EFG. Finally, we need to give a reason. Our reason is that all three pairs of corresponding angles are equal. So in maths, we open a bracket and we say A for three corresponding angles. If you ever use angles to prove similar triangles, you will always need to include the reason of A. Let's do another example. Prove that triangle DEF is similar to triangle JKL. Here we can see that we only have been given two angles in triangle DEF, 27 degrees and 108 degrees, but we don't know the size of our third angle E. So let's start by finding it. We know from our work with triangles that the sum of the interior angles of a triangle is 180 degrees. So let's make a note of this down here. This means that 27 degrees plus 180 degrees plus our unknown angle E will give us a total of 180 degrees. And we can use this information to find the size of the unknown angle. So we can say the total 180 degrees minus our known angle of 108 degrees minus the known angle of 27 degrees is equal to, let's take out our calculator, 180 minus 108 minus 27 gives us 45 degrees. So in this case, E is 45 degrees. Let's put 45 degrees inside our triangle as well. In triangle JKL, we also have an angle of 27 degrees and an angle of 108 degrees. And we've just found that 180 degrees less 108 less 27 is equal to 45 degrees, which means that just like E, K must also be 45 degrees. So let's make a note of this as well. And now we can consider the corresponding angles. D is the first letter in DEF. So let's mark angle D in red. J is the first letter in JKL. So J is the corresponding angle. Let's mark it in red as well. Now we can make a statement and give a reason. D and J are both equal to 27 degrees. So let's write down our statement. We know that this is true because the question has given us this information. So our reason is given. For the sake of explanation, I want to consider the information that has been given to us first. So let's skip E and now look at F. F is the last letter in DEF. So let's mark angle F in purple. L is the last letter in JKL. So let's mark angle L in purple as well. Angle F and angle L are both 108 degrees. So we can write the statement over here. This information has been given to us in the question. So our reason is given. Now we can look at E. E is the second letter in DEF. So let's mark angle E in green. K is the second letter in JKL. So let's mark angle K in green as well. We found that angle E is 45 degrees and we found that angle K is 45 degrees. So let's make the statement that angle E is equal to angle K. The reason why these angles are both 45 degrees is because the interior angles of a triangle always add up to 180 degrees. So as our reason, we say the interior angles of a triangle. What is very important to note here is that the sum of the interior angles of a triangle is always 180 degrees. So the interior angles of triangle DEF is 180 degrees, and the sum of the interior angles of JKL is also 180 degrees. We know that angle D is equal to angle J, which is 27 degrees. We also know that angle F is equal to angle L, which is 108 degrees. These triangles now have two pairs of corresponding angles that are equal. We also found that angle E is equal to angle K because both triangles have an angle of 27 degrees and an angle of 108 degrees, which means that E and K must both be 45 degrees. If two triangles have two pairs of corresponding angles that are equal, we can assume that the third pair of corresponding angles will be equal as well. We do not need to work out the size of this angle. We can simply make the statement that the third pair of corresponding angles is equal. So in this case, angle E is equal to angle K. And then we always use the reason interior angles of a triangle. Finally, we now have three pairs of corresponding angles that are equal. So we know that these two triangles are similar. So now we can say triangle DEF is similar to triangle JKL. And as our reason, we say A, let's put this into a bracket, for three corresponding angles. Let's do another example. Determine if triangle DEF is similar to triangle MNO. In triangle DEF, we've been given two angles, 49 degrees and 54 degrees. In triangle MNO, we've also been given two angles, 49 degrees and 77 degrees. Now, both triangles have an angle of 49 degrees, but the other two angles are different. So the first thing we need to do is find the third angle in each triangle. To do this, we need to make our statements and give our reasons. Let's start by finding angle F. We know the sum of the interior angles of a triangle is 180 degrees. So let's make a note of this down here. This means that if we add 49 degrees, 54 degrees and angle F, we will get a total of 180 degrees. And we can use this to find the size of angle F. So we can say angle F is equal to 180 degrees minus our first angle of 49 degrees minus angle E, which is 54 degrees. Now we can take our calculator and we say 180 minus 49 minus 54 is equal to 77 degrees. This is the size of angle F. We know this is true because the internal angles of a triangle add up to 180 degrees. So we use internal angles of a triangle as our reason. Let's put 77 degrees into our triangle as well. Now let's find angle O. In triangle MNO, we have an angle of 49 degrees and an angle of 77 degrees. And we can use this to find angle O. So we can say angle O is equal to 180 degrees minus 49 degrees minus 77 degrees. Let's take our calculator. 180 minus 49 degrees minus 77 degrees is equal to 54 degrees. This is the size of angle O. We found this angle using the internal angles of a triangle. So again, this is our reason. Let's put 54 degrees into angle O. Now, each triangle has an angle of 49 degrees, an angle of 77 degrees, and an angle of 54 degrees. So these could be similar triangles, but in order to prove similar triangles, we need to show that corresponding angles are equal. D is the first letter in DEF. So let's mark angle D in red. M is the first letter in MNO. So M is the corresponding angle. Let's mark it in red as well. Angle D and angle M are both 49 degrees. So we can write down our statement over here. This information has been given to us in the diagram. So we write given as our reason. E is the second letter in DEF. So let's mark angle E on our diagram in green. N is the second letter in MNO. So N is the corresponding angle. So let's mark this in green as well. Now angle E is 54 degrees and angle N is 77 degrees. So these corresponding angles are not equal. So we can say angle E is not equal to angle N. In order to prove that two triangles are similar, all three pairs of corresponding angles must be equal. If one pair is not equal, the two triangles are not similar. Even though the two triangles include the same interior angles, we already have one pair of corresponding angles that are not equal. Because of this, these two triangles are not similar. It does not matter whether angle F and angle O are the same size. The fact that angle E is not equal to its corresponding angle N means that these two triangles are not similar. So we can remove the green angles and we can write our answer as triangle DEF is not similar to triangle MNO. Let's do another example. Prove that triangle ABC is similar to triangle AED. Here, both of our triangles are in the same diagram. So let's mark triangle ABC in red. Triangle AED is the smaller triangle inside the larger one. So let's mark triangle AED in green. Now that we have a better idea of our two triangles, we can make our statements and give our reasons. A is the first letter in ABC, and it's the first letter in AED. So let's mark angle A on our diagram in blue. Angle A lies in both the red triangle ABC and the green triangle AEC. The angle doesn't change depending on the triangles we are considering. So angle A in triangle ABC is equal to angle A in triangle AED. So we can say angle A is equal to angle A. Angle A lies in both ABC and AED, so it is a common angle in both triangles. So as our reason, we write common. If we ever have an angle that lies in two or more shapes, we use common as the reason why they are equal. Now we can move on to B. B is the second letter in ABC. So let's mark angle B in purple. E is the second letter in AED. So E is the corresponding angle. E is an angle in triangle AED. So we only mark E1, the section of E that lies inside triangle AED. Now, the diagram already shows us that angle B is equal to angle E because both of these angles already have existing black curves. So now we can say angle B is equal to angle E1. We know these angles are equal because the question has given us this information. So we can put down given as our reasoning. Now we have two pairs of corresponding angles that are equal. From our previous examples and the interior angles of a triangle, we know that if we have two pairs of corresponding angles that are equal, the third pair will be equal to the third angle in triangle ABC is angle C, and the third angle in triangle AED is D1. So we can say that angle C is equal to angle D1. And our reason, we simply say the interior angles of a triangle. Now we have three pairs of corresponding angles that are equal. So triangle ABC is similar to triangle ADE. And as our reason, we write AAA because all three corresponding angles are equal. Let's do one final example. In the diagram, PQ is parallel to ST. Prove that triangle PQR is similar to triangle TSR. Now we need to write down our statements and give our reasons. The first thing we can see is that line PT crosses SQ at R. R is the third letter in PQR and the third letter in TSR. R1 lies in triangle PQR. So let's mark this angle in red. The corresponding angle R2 lies in triangle TSR. So let's mark this angle in red as well. Now R1 lies vertically opposite angle R2. And from our work with angle relationships and straight lines, we know that vertically opposite angles are equal. So we can make the statement that R1 is equal to angle R2. And we give the reason vertically opposite angles. The question also tells us that PQ is parallel to ST. So let's make our diagram black again and mark the parallel lines in blue. We know that if we have a pair of parallel lines cut by a transversal line, we can find numerous equal angles. PT cuts both of our parallel lines. So let's mark this line in purple. Now we've created a Z shape, and we know from our previous videos that if we have parallel lines, the angles we create in the Z shape will be equal. So in this case, angle P, it's marked in green, is equal to angle T. Let's mark this in green as well. Both of these angles sit inside the parallel lines, but on the opposite sides of the transversal line. Now P is the first letter in triangle PQR, and T is the first letter in triangle TSR. So P and T are corresponding angles, which means that we've now found a second pair of corresponding angles. So we can say angle P is equal to angle T. These angles are equal because they are alternative angles. So we can use alternative angles as our reason. But we also need to indicate why P and T are alternative angles. And this is because PQ is parallel to ST. So we can give this as our reason as well. Now we have two pairs of corresponding angles that are equal. And if two pairs are equal, the third pair will be equal as well. Our third angle in triangle PQR is angle Q, and the third angle in triangle TSR is S. So we can write angle Q is equal to angle S. And as our reason, we say interior angles of a triangle. Now Q is the second letter in PQR, and S is the second letter in TSR. So these are corresponding angles. This means we now have three pairs of corresponding angles that are equal. So we have proven that these triangles are similar. So our final answer, we say triangle PQR is similar to triangle TSR. And for the last time, we give our reason as A.